everyone, this is Kalpana here. In this video, we are going to find or solve a problem, differential equation from higher order linear differential equation. So let's get going. Problem: solve d square y by dx square minus of a plus b into dy by dx plus aby equals to e power ax plus e power bx. So we are given f of d into y equals to e power ax form. Okay, we are given a differential equation in this form where a is a real number, which means that a and b are real numbers. Fine. Now let's find firstly the order and degree of the given equation. So find or identify the highest derivative. Here d square y by dx square is our highest derivative. So 2 will be our order. And the power of or the highest power of the highest derivative will be our degree, right? If you have another d square y by dx square and if it's have whole power cube, then our degree will be 3 because the highest power of the highest derivative is our degree, right? But we have degree 1 in this problem. Now coming to the solution. Given differential equation, d square y by dx square minus a plus b into dy by dx plus aby equals to e power ax plus e power bx. Since we know that differential operator d equals to d by dx, so we'll write the equation in differential operator form, right? So you'll get d square y minus a plus b into capital dy plus aby equals to the RHS part, right? If you notice, you're having y in all these three terms of LHS. So let's take y common from all these three terms of LHS. You'll get d square minus of a plus b into d plus ab into y equals to RHS part e power ax plus e power bx, right? So which is in operator form. F of d into y equals to q, where f of d equals to d square minus of a plus b into d plus ab and q equals to e power ax plus e power bx, right? So now we'll find the solution to the given equation, and the solution is given by y equals to complementary function we name it as yc plus particular integral we name it as yp, right? We'll get yc from auxiliary equation of f of d into y equals to 0. We'll just make q to 0. Then you'll get f of d into y equals to 0, right? From this, that is from homogeneous equation, you'll get yc using auxiliary equation, or we are already given a non-homogeneous equation, okay? By considering homogeneous equation of this non-homogeneous equation, we'll get yc and we'll get yp using 1 by f of d into q. So let's see. Firstly, we'll find yc, okay, using auxiliary equation. The auxiliary equation d into y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d, right? So let's replace this differential operator d by m so that you'll get f of m, which is equals to m square minus of a plus b into m plus ab, right? Then our auxiliary equation will be m square minus of a plus b into m plus ab equals to 0. Now we need to find roots to this auxiliary equation, or you can find factors to this polynomial. I'm not talking about the equation, I'm just talking about the polynomial. You can also find factors to this polynomial, right? Now you'll find roots. Minus am minus into plus minus bm plus ab equals to 0. Now take m common from the first two terms, you'll get m times m minus a, and take minus b common from the next two terms, you'll get minus b times m minus a equals to 0. See, minus b into m is minus bm, minus into minus plus a into b, a, right? If you notice, we are having m minus a in both the terms, so let's take m minus a common from these two terms, we'll get m minus a times m minus b. Now equate each factor to 0 to find m. Okay, let's equate first factor to 0 and second factor to 0. You'll get m equals to a from this and m equals to b from this. So you got m equals to a and b are the roots of f of m equals to 0, or auxiliary equation, right? Which are real and distinct. So if two roots, say m1 and m2, are real and distinct, then our complementary function will be c1, one constant into e power one root into x plus another constant into e power another root into x, right? So here a complementary function is given by yc equals to c1 e power root into x plus c2, another constant into e power the other root, b into x. So we got a complementary function here, right? Yc equals to, it's not visible. We got yc equals to c1 e power ax plus c2 e power bx, right? Now let's find particular integral. So let's see how to find particular integral firstly. Yp is given by 1 by f of d into q, for q being e power some ax. Okay? E power ax. Here first you'll find f of a. Okay? If f of a is not equals to 0, you'll get yp equals to 1 by f of a into e power ax as your particular integral. What happens if f of a is equals to 0? Then you need to find f dash of d. Okay. Then you'll get yp equals to, put 1x. Here you don't have any x, okay? We'll just start here. we'll put 1x and we'll find f dash of d into e power ax. Okay, here we have to find again f dash of a. If f dash of a is not equals to 0, then we'll get the solution yp. It is x into 1 by, we can replace f dash of a since f dash of a is not equals to 0, right? Then this will be the solution. If not, if f dash of a equals to 0, again you need to find f double dash of d. Okay, so we'll consider yp as already have one x, put another x into 1 by, you'll find f double dash of d, right? The derivative of f dash of d into e power ax, right? So from this you'll get x square into 1 by f double dash of d into e power x. So now we need to find f double dash of a. If f double dash of a is not equals to 0, then yp will be x square into 1 by, you can replace the differential operator in f double dash of d with a. Then you'll get 1 by f double dash of a into e power ax as your particular integral. Otherwise, if f double dash of a equals to 0, then you will find f triple dash of d. Okay, again you'll just continue the same process. Okay, you'll include, here already have x square, right? So you'll include 1x into 1 by f triple dash of d into e power ax, and again you'll find f triple dash of a. If it is not equals to 0, then fine, you can substitute f triple dash of d. Simply you will substitute d equals to a and you'll find yp. Otherwise you need to again follow the procedure. You'll find f power 4 of d. So let's see in the problem. We are going to find particular integral now. Yp equals to 1 by f of d into q, right? Then yp equals to, we have f of d, d square minus of a plus b into d plus ab. For q, e power ax plus e power bx. Again you can write this as d square minus 1 by d square minus a plus b into d plus ab into first term of q, e power ax plus 1 by d square plus a plus b. This is minus, right? You'll get minus of a plus b into d plus ab into second term e power bx. You can find each, you can just consider as particular integral 1, particular integral 2 for our convenience. Okay, you'll find separately. First we'll find this. We have yp equals to 1 by d square minus of a plus b into d plus ab into e power ax, and another term d square minus of a plus b into d plus ab into e power bx. So let's find the first one. Okay, 1 by d square minus a plus b into d plus ab into e power x. You can just write this as 1 by d square minus ad minus bd plus ab into e power x for our convenience. Okay, now we'll find, we are having f of d equals to d square minus ad minus bd plus ab, right? Now we'll just find f of a is simply, we'll get a square minus a into a minus b into a plus ab, which is equals to a square minus ab plus ab, right? Ab minus ab gets cancelled, minus a square plus a square gets cancelled. So finally you'll get f of a equals to 0. Since f of a equals to 0, so you can't substitute or replace d by a. So next what we have to do, we'll put 1x into 1 by, find the derivative of this one, right? That is f dash of d is 2d square minus derivative of this one is 1 minus a, you'll get, and minus b. So you'll find f dash of d into e power ax. You can just write f dash of d instead of writing f dash of d, okay? For just to show, I wrote f dash of d. You can just write directly 2d minus a minus b. Now we'll see, we'll find f dash of a. You'll get 2a square minus a minus b. See here, f dash of d is 2d, not d square, okay? You'll get 2a. And 2a minus a is a minus b is not equals to 0. Since f dash of a is not equals to 0, then you can replace d by a. Then you'll get x into 1 by a minus b into e power ax. Okay, if you want, you can just write here f dash of a, right? Since f dash of a equals to a minus b, which is not equals to 0, so you'll get x into 1 by a minus b into e power ax. Okay, so we got first value, that is pi of 1 equals to x into 1 by a minus b into e power ax. Now let's find the second one. One by d square minus of a plus b into d plus ab into e power bx. You can just write this as 1 by d square minus ad minus bd plus ab into e power bx. So now we are having f of d equals to d square minus ab minus, sorry, this is d, minus bd plus ab. Now let's find f of b. We'll get b square minus ab minus b into b plus ab, which is equals to b square minus ab minus b square plus ab. Here plus ab minus ab gets cancelled, plus b square minus b square gets cancelled, and you will get 0, right? Since f of b equals to 0, so what we have to do, we have to write 1x, 1 by, you need to find f dash of d into e power bx. So let's find f dash of d equals to 2d minus a minus b. Now what we have to do, we have to find f dash of b equals 2 into b minus a minus b, which is equals to 2b minus a minus b. 2b minus b is b minus a, which is not equals to 0. Since f dash, okay, you can write one more step, right? We just wrote f dash of d and we have not mentioned what is f dash of d. So we'll write f dash of d here, 2d minus a minus b into e power bx, right? Since f dash of b is not equals to 0, then you can write f dash of b value in the denominator. Okay, you get x into 1 by, simply we are replacing the value of b in d. Okay, replace b equals to b otherwise. Then you will get 1 by b minus a into e power bx, right? So therefore, pi2 equals to x into 1 by b minus a into e power bx. Now, we'll write yp. Coming to yp equals to, the value of first term is x into 1 by a minus b into e power ax plus value of second term is x into 1 by b minus a into e power bx, right, is equals to, let's take minus common from the denominator of second term. We'll get x into 1 by a minus b into e power ax plus x into 1 by, take minus common, then you'll get minus of a minus b into e power bx, which is equals to x into 1 by a minus b into e power ax plus x into, you can write 1 by minus of a minus b as minus 1 by a minus b into e power bx, right, which is equals to x into 1 by a minus b into e power ax plus into minus is minus x into 1 by a minus b into e power bx, right? So you can find common terms in both the term. You're having x by a minus b common in both the terms. So let's take x by a minus b common from these two terms. You will get x by a minus b into e power ax minus e power bx, right? We can also write this as x into e power ax minus e power bx by a minus b, or x into e power ax minus e power bx by a minus b, which is a particular integral. So therefore yp equals to x into e power ax minus e power bx by a minus b. Now we can write the general solution. Therefore the general solution is y equals to yc plus yp is equals to c1 e power ax plus c2 e power bx plus yp, x into e power ax minus e power bx by a minus b. Therefore y equals to c1 e power ax plus c2 e power bx plus x into e power ax minus e power bx by a minus b is the required solution. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you next video. Until then, bye bye.